Hey guys, Koda Canis here. Welcome back to the bench. Got an interesting one today. It's got a little daughter board with it, with one of these black, I suppose it's epoxy mounted chip. So I don't know what that's going to do. Got a speaker, so it's obviously going to make some noises, as it says on a speaker. And it's got a CD4066, which is that one, and a CD4011, which is that one. So I had a quick look at the data sheets, and so the 4066 is a CMOS quad bilateral switch. So for multiplexing, okay. And the 4011, which is this one here, it's a quad 2 input NAND gate. So I haven't done the circuit analysis for this one. I might take some pictures with me and make sure. But yeah, just a weird one. I mean, there's a lot going on. There's 4 switches down here. Some resistors, a couple of diodes, capacitor or 2. Again, it's got an input, but the kit didn't come with a voltage source. So, but given it's CMOS, I presume, what's that, 5 volts? What's the input? DC supply voltage rail minus 0.5 to 20 volts. Okay, probably could supply rail voltage 3 to 18 volts recommended. Okay, what about the other chip? Other chip is input voltage. Oh, come on. Flicking through 5 volts. 15-volt digital plus or minus 7-volt peak-to-peak switching. Okay. So just flick through here. DC supply voltage. Okay. 20 volts is max. There you go. Supply voltage operating 3 to 18. Okay. So this will be another probably 9 volt. All the other ones I've had are 9 volts. So yeah. You look at this, it's all ganged up. And so what I will do is before I start building this, I shall take a couple of photos and then I'll do some reverse engineering. I'll come back with the actual that one. I'll take a snapshot of that small one. Nothing on the back. Right. That's an offline project because that one's going to take some time. So let's get the soldering iron going. Let's get this made up and see what it does. I'm intrigued because I've never tried building one of these with a daughter board before. So I'm presuming that just sits there. Well, the dots line up. And then I must well run a couple of standoffs. That's weird. Never had one like this before. But that seems to make sense. Doesn't sit there, does it? No, they don't line up, do they? They do, but they don't. Yes, I think we mount it that way, and then we use some of the offcuts. Anyway, what we got while that's warming up? A couple of those. What are those? They look all the same to me. What are they? Brown, green, yellow. We've got multiple brown, green, yellows. And some blue, red. It's a blue, red, yellow. That's a red, purple, yellow. That's a good old 4 color resistors. So let's see what the magical 4-bar resistor chart says. So those ones are, what do you reckon? Brown, brown, green, yellow, I think. So it's 1, 5, and 4. So it's 1, 5, 0. That's 150k. So there's me 150ks. Then I've got 2 red, purple, yellows. That's 2, 7. It's 270k. Oh yes, I got 270k there. Yep. This one is a blue, red, orange, which is 6, 2, 3. So that's 62k. Don't see any. Oh, hang on a minute. Okay, and that one's a blue, red, yellow. So there's my 620k, which is, oh, that's 62k, 620k. That's why it's confusing me. A couple of diodes, a capacitor, and a bigger diode. So I'm presuming that one and that one are these two, because they're the same size, and that one is the bigger one. Switches, header board. Oh, what's this one? God, that'll make these print writing small. 8050 SS805 SS8050. Let's see what one of those is. SS8050. Oh yes, it's transistor. What sort is it? It's NPN. No, it's just a standard NPN transistor used in Class B amplifiers. Ooh, that's interesting. So, hang on a minute. I'll just put my. Excuse the slight rustling. I'm just putting on my magnifying goggles. And by that I mean set of these, so I can actually see what I'm doing. Right, that might make life a bit easier. Yes, much easier. I can actually read stuff now. Alright, let's check. Okay, you can hear me okay? Let's get going. Right, so what do we got here? These are the 150s. And where did I put my... Oh, I tidied it up, didn't I? Hang on a second. Oh, I didn't. There we go. Let's get this thing out. And we need... Yeah, that first block. Use a little tool. Let's see, is it the right size? No. I want it to go there. Oh no, dear me, that's not big, not tight enough. Let's try this one. Right, let's see, let's put tolerances to that side. Oh, even then that's a little bit on the tighter side, but that'll do. 150. Let's get this slot in. Yeah, sorry it's been a bit quiet on the channel recently. I've been a combination of having a bit of a holiday, been a bit ill. It's always not good when the kids go back to school and you end up picking up everything the kids do. But hey ho, we're back to it. Christmas is all done and over and back to work and all that jazz. 150 there. Yeah, what we got? 150 there. 150 here. So, given the fact that if I'm looking at this, you have 4 pull-up resistors, I'm guessing. I haven't actually had a look at that. I haven't pulled the circuit diagram for this one yet. But I'm guessing these are probably pull-up resistors. 4 switches. So I bet you can switch and choose what music it makes. Or note or sound or... It'd be an interesting one actually. And then all the sounds probably programmed onto that thing. The other 150. Where's the other 150? There. Oh, got a spare 150. Okay. Well, these were red, purple, yellow. Red, purple, yellow is 27 and 4 zeros is 270k. Oops. 270k. There's one. But yeah, I'm interested. I don't know why they put like a CMOS on it. Wow. I mean, that's stuff I played with years ago. Back in the days when you're doing your old electronics degree, you start playing with the spare. What's this one? Playing with CMOS. This is blue, red, yellow. So blue 620k. There you go. 620k. Come on. There, and there we go. All right, what's next on the list? So this one is blue, red, orange. Blue 6, 2. Orange is 30, so 62k. I'll start getting into the smaller stuff yet, which is the old surface mount. I will at some stage. I found out what looks like an old test training kit for soldering, which will be interesting to do at some stage. I have to get the old hot air gun out and let's see. What's this one? This is a 4007. Yeah, ubiquitous diode. And these two obviously go there and there, and yep. I can't remember what you call these glass encased ones. I don't know if these will be Xena or just standard diodes, but hey, put them in. Oh, they're a 4148 diode. Whoever made these kits, I'll give them credit. Their silk screen is very, very well done. They definitely don't let you make mistakes. Right, that is all the small stuff done by the looks of it. Yep. Right. Now where have I put my wire cutters? Nope, I have put those away. Excuse me for a second. There. Cool. Let's get to it. A bit of solder. Put that through there. Cool. Alright, now where are we going to start? Let's start down here. Come on, you're hot enough. I know I haven't used you for a little bit, but don't get grumpy. Temperamental soldering on, that's all you need. Oh, dear me, that's atrocious. Not better, no, not better, but it'll do. I think these might be slightly tarnished, this board. I should have cleaned it before I started soldering it. So it's taking a little while to... I feel like it's taking a little while to activate properly. But yeah, as long as we get decent joint. They're a bit messy, I'm not going to complain too much. If I was doing this commercially, then yeah. Make sure it's in the middle of the screen for you. Right, how are we going? the footage, make sure my big head's not getting in the way. Come on, there you go. And that one. As I said, if this is interesting, I'll probably sit down offline, figure the schematic out, and then do a addendum to the video. Problem is I can't do some of it because that chip that's covered in epoxy is not going to be able to be figured out. It's probably the same one they have on greeting cards. If you ever pulled a greeting card to bits, you'll find that quite often they just have a circuit board in there with a one of those black epoxy lumps on it, and never managed successfully, not that I've tried much, to actually pull the epoxy off. Depotting, I think it's probably what it's called. But it's probably not going to tell you much. Apart from the fact that there's a chip there with some. It's probably just bonded. Probably it's not even a chip. It's probably just bonded. The what's it called? Die is probably just bonded directly to the circuit board. Probably cheaper that way. Don't have to worry about plastic encasing and all that sort of jazz. All right, how are we going? Couple more left. How are we looking? It's not bad. Keep those to one side because I think we're going to need those for the daughter board. Come on, that one. That one. Oh, we got a couple more here. That's all the, well, I say all the easy stuff done. The dual inline sockets are the easiest ones to do. You just walk your way along, zip, 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 done. Oh, come on. Thank you. All right. It's not bad. Oh, they're a bit warm. Funny that. Soldering iron, nice and hot against metal, and you can complain it's getting hot. Right, so what's next, you reckon? Switches I'll leave to the last. All switches. Not a lot of soldering on this one, but never mind. Right. That one, there's a notch. Match it with a notch on there. And 2. Oh, slightly bent. Get in there. Ow. Oh. It's not so useful. Oh, I wonder if it's really bent. God, these things are flimsy. There we go. Push it back in. All right. That's repaired. Let's try that one again. That way around. Let's try a bit of plastic. Come on. That looks better. These things are really flimsy pins. I used to have some better ones, but I can't seem to find them in my drawers at the moment. So ones that come with the kit will have to do. All right. Let's just put that down. Tack those on. so they don't fall off. Pin number 1. Pin number 1. Better do one on the other side by the looks of it. Let's just do that one there. And that'll stop it standing up like it just did. That's cold. Right. Yeah, lying flat. There we go. Okay, so repins the transistor. Two pins the cap. Plus on the speaker matches plus there. Don't fit. Oh, that's annoying. Right. Actually, let's not do that at the moment. Yeah, let's get these two in, and then I'm going to solder that board on, because it's going to be annoying by the looks of it. Never tried a daughter board like that before. Oh, come on. Thank you. Thank you. Around. Nice and quick so we don't heat anything up. Right, that's all done. It's good. No, that's good. Feel too hot. So we've got switches to do. But I'm going to get this daughter board on first, I think. Right. How do you suggest we do this one then? I reckon. Yeah, the problem is it doesn't fit neatly. If you have a look, the holes kind of line up. Well, these, yeah, they don't. They do if you do there. That gets the 4 of them. I get 3 of them to line up all right. I think the best bet will be just to solder some of these there. If we solder that one that way, like that, so end on, now I should have to bend it flat, you reckon, so it'll come up and over. It's worth a try. Now, how am I going to solder this? Where'd my helping hands go? Rummage. Nope. It's crash, bang. Let's get one of these on. And there are the arms. A couple of arms and a couple of wires, since I'm over here by the... no, that looks useful. No, that one looks too useful. Oh, come on, I've got some... here we go. Old fan wire, that'll do. Pull that one of those to bits for the... So this... Alright, you... Alright. You hold on to that one, please. Hold on to that. Oh, come on. Right, that's going to be annoying. Doesn't quite like bending that way, so let's just move it. just sit like... No, don't push yourself down. I need to stand that up a bit. Because it wants to sit there at that height nicely. Come on. Right. This would be really useful if I had another person sitting here, but never mind. Let's see how this works. Oh. Oh, that worked all right. Nice and flexible wire. No. Helps if I actually pick up the direct things. Nope. Don't throw it on the floor. Code. We'll just get annoying. And don't drop it. So this thing must be... Well, if it's got multiplexing... it's got 4 buttons. It's not exactly... a trivial little micro. I suppose it could be one of those, was it Padox or one of those ones you get, you know, the one-time programmable ones you see now coming out of China, which are actually meant to be surprisingly very, very good. And then they cost a few cents each, so they are one-time programmable, and I don't have any of those. Oh, it's not what I wanted. Actually, wow. The old solder is staying quite liquid on there for a long period of time. Surprising. I mean, unsurprising. Surprising. Sorry, not unsurprising. Right. This is working out not too bad because I can get... Ah, come on, get in that hole. Oh, it's sitting there. I'm going to put some flux on here, I think, because those... They take forever to cool. Is this board getting hot? Not particularly. Oh well, standard approach. If at first it doesn't quite flow right, get something on there and then flux it. Right, so that was... no, I need another... Oh, this is a big one there. I don't know how I'm going to do that one. So 1, 2, 1, 2, 3. So I need 1, 2, and that one. But they come from the other side, I think. First off, they're pretty poor joints. Oh, sorry, that's been completely off screen, probably, isn't it? Where have I got it? Some flux. Let's get some liquid flux going. And let's get these joints resoldered and flowing. Oh, that one's fallen off. That one's fallen out. Oh, great. There. That board is holding the heat. Something phenomenal. The solder is staying hot. Or, not hot, sorry. What's the word I'm thinking of? Liquid. Absolute ages. That is ridiculous. Right. Ah, that's why that one's not right. It's not even in the hole. Right, that is better. Look a bit more like solder joints now. Not great solder joints, but solder joints. A couple others. That one. The reason I keep so many of these things around, they're quite useful for doing this. Right. So if I go one, I need two. One and two. Oh, need to clean my fingers. I've got flux stuck to them. One there, and that one there. Push that one in a bit. Come on, in here. Thank you. Right, I said to them, about these guys has a really good solder mask. Well, the solder mask is good, but have you ever daughter board like this? I suppose it's different. At least you don't have to worry about heating up the component at the other end of this leg too long. Well, that's not very good. That one needs a bit more solder. Come on. Come on. Don't know what this board is coated with, but the solder is not. Stays. What's the word? You clicked the one which basically means it's in a weird semi-liquid state. So I reckon I'll put that one in last. Actually, no. I reckon that should just solder up alright, actually. Put a solder on it around that hole. No, you get out of the way. Nice try, guys. Come on. Let's make a nice, decent solder joint. Oh. There. How's it look? Not great, actually. Let's just sit it there. Yeah, that works. Then prompt you stand. It's taking absolutely forever to. That's got a positive to it, so that must be the positive. What's the word? Rail. So there is my porcupine. So the idea is, if I put 1, 2, that one there, that one there, that one there, that one there, there, and bend that one up and into that hole, and push it down and rotate it like that. Almost going to go in. There we go. Right, that's solid there. Now we bend that one down. Whoa. Through the hole. Come on, get into that hole, please. Just go in. There. Yeah, brute force and ignorance wins eventually. That's one. Oh, and the other one fell off. Taking the track with it. Oh, boom. Right, put that through here. That's going to need an interesting bridging blob, I think. Actually, pull that up a bit. Too much force, but no. We can do this now. That goes there. And straight down. Why can't you just go straight down and be nice? Because of course you don't want to be nice to me. Oh, I think I must have got a really strong lead. Ah, now I just broke it. Okay. This is going to be one of those days, is it? Straight up through there. Now, luckily, that is all alone at the top, so let's get the other one soldered in, and that'll get the board stable, at least. But yeah, that was annoying. I haven't ripped a track off a board for many years. But as I said, brute force and ignorance, and this time ignorance lost. That'll look pretty good. Now, that's why you always wear safety goggles, kids. That one snapped off and smacked me in the face. Luckily, I've got goggles on. Right. Yeah, rip the track off there. So let's put this one in. And come on, rotate through the hole. Thank you very much. Let's get it soldered down here so it's not going to go anywhere. All right. I think I might be a little lucky here. I'll trim that off. Because the way that that's sitting, I think if I can cut it off short, I don't know if that's coming through very much, but I've ripped off the track here. Yeah, you can see here I've just damaged the track. Solder's pulled the pad off, so I'm just going to put some solder right on this corner and try and bridge it across to this bit that's over here. And that should just scrape off a bit of the... Doesn't look like it's actually got a solder mask on it. Put a bit of flux to make stuff flow nicely. Right. Sit there. And that's the other reason you do with this in a well-ventilated space, kids. Flux is pumping off a reasonable amount of fumes. Well-ventilated, well-lit space. Unfortunately, part of my studio lighting's not working at the moment. It's always a bit darker than normal. Come on. You are going to be a right pain, aren't you? I've got some solder on the track. It doesn't want to stick to the leg. That's weird. Because I cleaned that one off. Come on. Stuck to the track, but not to the... I don't really want to cook the circuit board, which looks like I'm doing at the moment. Oh, come on. Oh no, don't wipe the solder off. Come on. Aha. I think that looks like it's making contact. It's not the world's best fix, and I've definitely, not sure if I scorched the board or maybe just burnt some flux. But yeah, that was a pain. I really don't like that daughter board. Never mind. A couple last things to do, and then we'll turn it on and see what happens. Speaker. Switches. Don't seem to matter which way they go. 1, 2, 3, 4 switches. And I'm not going to put this in at the moment, I don't think. That looks reasonable. I should have done those before the daughter board. All right, that's future code's problem. Let's just get everything else soldered up. All right, okay, quickly solder up these boards. So solder up these boards. I mean, solder up the these chip sockets. Don't really rate those sockets because they've got such thin legs. But hey, I'd say this is a kit for fun, not a kit for commercial. I wouldn't be using these cheap pressed tin, I suppose. Sockets. I'd be using proper turned pin. Or soldering the chip in directly. I know some people disagree and say that sockets are a good idea for easy maintenance, but you get intermittent contacts at times and all sorts of fun and games. Come on, solder up. There you go. And that one. And that one. And that one. Go on. There you go. That's all good to me. All soldered up, no dry joints. Not great joints in places, but a bit too much solder on some of them, which is weird. Right. Now so we're going to try and figure out how to do these. But I'm just going to take a quick break, so I shall be back with you shortly. Right, so sorry about that pause. The internet was having a few problems, so let's get this lot on. One. Actually, might just be easier if I put that. Right, actually, that might be. Oh god, those magnets are strong. I put one there, put it there. How about there? That will work. Oh, come on, just. All I need you to do, you stupid hands, is hold the board. Yeah. Oh, you're not going to do it, eh? I always need a bigger board than the base plate I've got. Because I need to go 1, 2. I mean, I could just zap them down with a bit of glue, but that seems hideously pointless. Actually, I know what I'm going to do. Cunning plan. Let's see if it works, eh? I have good old-fashioned masking tape. So it's good that way. And put it to there. Is that going to hold? Looks like it's going to hold enough for me to just zap. Because I don't need to do the two ends because they don't appear, they're not electrically connected to anything. So come on, that one. One. Oh dear me. That's better. Yeah, so I'm beginning to suspect that this is like a musical Christmas card where you can select the tune. If so, should be pretty cool. Alright, how are we looking? Not too bad. Ooh. Not the most straight switches. Alright. Put that out of the way. Quick inspection. Everything seems to be soldered. Yep, just got plus or minus to put in there. One of these old plugs around, so I'll steal some of the cables. So we go, let's see, black, and we'll go blue. Wire strippers, wire strippers, wire strippers, where would I be? There I am. This came from an old PC fan, actually. I think, yeah. Yeah, 4-wire fan. Alright, so negative goes there. Positive beside it. Let's just do one at a time. Come on. There we go. Positive. Negative. Put the chips in. And let's see what happens, eh? Cool. That looks good to me. Trim those off. Right. So what we got there? So that one's a 4066. 4066. Notch matches notch. Right number of pins. Wow. Not very aligned. This is a anti-static soldering mat, so it's pretty good for that sort of thing. Right, and the last one. Now what's this one? This one is the 4011. Let's bend the legs a bit straighter on this one. 4011. Yep. Notch this end, notch that at this end. All pins in. All right. Moment of truth. Right. Yeah, there we go. There's the power supply. Turn soldering on off. Or I'd stick my hand in it again. 9 volts. Current limited to a few milliamp. That one goes there. That one goes there. Let's see what happens. Don't know if you can hear that, but well, that's going to be very annoying, but hey. So drawing, wow, 200 milliamps. Got this down to, let's see, 5 volts. Let's see what happens. Quite tolerant, isn't it? Interesting. So there you go, guys. It's just as we suspected. That's a little sound producing chip. These ones here, obviously, that pulses. As I said, I'll get the diagram out now. I'll reverse engineer this. But that's my next job. But we have a working sound generator. That was fun. Daughterboard made it very difficult to build, or annoying to build. But I hope you found that enjoyable. And as I said, I'll get the circuit diagram up, I'll do some reverse engineering, and I'll be back shortly.
Hey guys, thank you for watching me build that circuit. Addendum, this is a few days later. If you go have a look on my channel, I've got another video where I reverse engineer the circuit board. I'm not going to take the credit for this one. This one was found while I was searching for the actual part number. So go have a look. It's an interesting bit of piece, but basically you have your switches here which select which sound effect and how fast they go, some various logic to drive a 9561 soundboard. So go have a look at my other video, like and subscribe, and I'll credit the person where I found this from in the description below. So I'll catch you later. Bye.